Imagine you have a computer program that does multiple things at once, like downloading a file, playing music, and showing you a video. You might think these things happen at the exact same time, but they actually take turns using the computer's brain, called the CPU. This sharing is so fast, it looks like everything is happening simultaneously, and it's called concurrency. It makes your computer seem like a superpowered multitasker. But there's another reason why concurrency is important. It makes sure the CPU doesn't waste time. Let's say the program is waiting for the internet to send the rest of the file. Instead of just sitting there, the CPU can switch to playing music or showing the video, and then come back to the download when it's ready. This way, the CPU is always busy doing something useful. Now, think of a program like a big house with many rooms. Each room is like a process, a separate space where part of the program runs. Processes are great for keeping things organized, but they can also be a bit slow and clunky. Imagine having to walk all the way to another room every time you need something. That's where threads come in. Threads are like little helpers inside each room. Process. They can do things concurrently within that room without having to go anywhere else. So, instead of waiting for one thread to finish downloading the file, another thread can start playing music right away. Here's what makes threads special. They share everything in the room. Just like helpers in a room can share the same tools and furniture, threads can share the same memory and resources as their process. This makes them super efficient. They each have their own to-do list. Each thread keeps track of what it's doing with its own program counter, like a personal checklist. This allows them to pause and resume their tasks without messing up other threads. They need their own space. To avoid tripping over each other, each thread also has its own stack, like a personal workspace. The stack holds the thread's current work and information. They can be created on the fly. You don't need to plan for every single thread beforehand. A program can create new threads as needed, like calling in extra help when things get busy. Going back to our house example, think about a server that sends pictures to people who ask for them. If the server used separate processes for each request, it would be like having to build a whole new room for each person. This would take a lot of time and resources. But with threads, the server can handle multiple requests in the same room. Process. It can have one thread listening for requests, another thread finding the picture on the hard drive, and another thread sending the picture to the person. This way, the server can use its resources much more efficiently and respond to requests quickly, even when lots of people are asking for pictures at the same time. So, threads are like tiny, nimble helpers that make computer programs faster and more efficient. They allow programs to do many things concurrently, even on a single CPU. Threads are a powerful tool used by programmers to create the smooth and responsive software we use every day.